No, actually, no, yeah, so.
Negatives. Over.
Two? Yeah, so it's the same as two. That's negative eight.
What's time for?
Negative. It's positive, it's just negative three over two. It is just.
Alright, well, X is
Negative. Oh, wait, it's negative. So it would,
So I think it's just,
like 8:35.
negative 335, negative 635, negative. I think it's just one half. Down that way, sign the y value. Y value is sign is one.
Yeah.
It's 1.5. No. Like six.
Yeah, and then negative.
The y. All right now.
Yeah.
Right, no, because you have negative.
Yeah.
You have two hybrids. What?
15 seconds.
So that's a thing. But what if?
Oh, it's like, I know it is, because this isn't it all to the.
Okay, so. I'd like to know, what did you discuss? What is a function? I would like to know from the one and only Mitra. What's a function?
I like knew it, I was gonna be called, a function is like. I didn't know it exactly.
So what do you think? Would you say it's one of those things that you kind of have an understanding of, but it's hard to
Yeah.
put into words? Did anyone else struggle with that? Like, you're familiar with functions, but maybe putting it into words was a little difficult. Yeah, Baron? Yes.
I'm just saying that like as X does this, Y does this.
Good question. Is that what a function is?
Like as X changes in this way and is modified by these other things, Y does that.
Okay, so and X is some sort of like input.
Right. Where it's like X gets put in squared and then added 4. It's 1.
Nice. Okay, so it's like a journey of a number. You start with something and then something happens to that number and it may evolve into something else. Okay, so that's a good idea of what a function is. Yeah, other.
To expand on what I'm saying, I think a function is essentially a relation between an input and an output where one input correlates to one output.
All over the.
Have you written math books at some time in your life? Okay, I knew it. No, written math. I was wondering if you've written. Yeah, written. No, not yet. Growth mindset, not yet. Nice. Does that sound familiar? Anything else about what a function is? I know you know about different functions like odd and even functions. Those are characteristics of special functions. You know, parent functions and things like that. Yes.
Like for everyone, you put your streams out.
Yes. Nice. Yeah, there has to be exactly one output, so that goes along with what you were saying. Good. And it does have to do with inputs out and outputs. Baron, I really like how you described it as kind of the story of a number. It goes in, it goes through some sort of process mathematically, and then you come out with it. Cool. And we're going to be talking about that a little bit today, but before we do that, number 2, obviously you take that -2 and you find the sign of -2. No, should we distribute that sign? No, that'd be ridiculous. Yeah, so I guess there's kind of a story about this number. This -2 goes inside here. It becomes what? -8 pi over 3. Is that right? Who could tell me the rest of the story? How did you do this problem? Baron for 200.
I said -3 pi over 3 and then -6 pi over 3. And then I went down 2 more pi over 3s, which got me to an angle that's the same as 240 degrees.
Okay, so it looks like this is kind of your story.
Yeah.
Okay.
And then I was like, oh, sign Y value -√3 over 2.
Okay. Nice, thank you. Did anyone think about it differently? Yeah, Hannah?
But like, instead of thinking about like it in terms of like 3 pi and 6 pi,
Mhm.
I just kind of made it into a mixed number. So I know that 3 goes into -8, -2 times, so it's like -2 2/3 pi.
Sure.
And then I just got rid of the -2.
So could you always get rid of just the whole part of that number, or how could you just, why is it you could get rid of the two?
It's like 2 pi is just a full rotation, so.
Okay. That's kind of nice, isn't it? If it would have been like one and,
Yeah, that I was wrong.
okay. I like that. Thank you. Did anyone think about this differently? Yeah, Rona?
Those signs of function mistake that about shows negative sign 8 pi/3. And then 8 pi/3 is just 3/2, or root 3/2.
So this part is √3/2, and then you stuck on the negative. What do you think? Does that make sense too? Okay, another way to do it? Okay, I think it's nice to hear different ways of how people work through this. I noticed that you thought about 240 degrees. Is that what you said? 240 degrees?
Yeah.
I think you said that. So yeah, I hope you're comfortable with degrees, but I hope you're also comfortable with just staying in radians. Did anyone not consider degrees at all when they were doing this problem? Just you stayed in radian mode in your brain? Nice. I do want you to be able to do that. So hopefully all our work with the unit circle quizzes helps get there. By the way, you think the unit circle quizzes are over?
They're not.
We'll see.
Is it a new set or like?
No, that's the no new
If you've
information.
already gotten it right.
Yeah, then you're good. It's just for posterity. Oh, we have a new packet. Let's talk about it. You can see it's actually a pretty short unit. And the first day today is supposed to be previous knowledge. So we're going to be talking about composition, functions, one-to-one inverses. Do those phrases make sense? Do they sound familiar? Somewhat. We'll be talking through them. And then inverse sine. Oh, that's good stuff. Oh, there's going to be a quiz first day of November. And a test. November 12th.
November 1st,
Yeah,
so the Friday after Halloween, there's tech.
Yeah.
the day after. And no candy allowed.
Yeah, is that really like? But still, like.
Wait, so
Always a comment.
It's a-
the quiz would count, like the first quarter, but the time wouldn't.
Oh, good question. I think that the end of the first quarter is Friday. Is that right?
So
So I'm not sure. It depends when I grade it. It's likely that it won't, the first quarter. It'll definitely count for the second quarter, as will the test. Okay. Today is chock full of stuff. And again, this is a review for many people, but I'd like to talk about this from the very beginning. Because it's a very good place to start. I just want to make sure we all are on the same page. Composite functions. Does this sound familiar? Wait, discuss with the neighbor. What is a composite function from what you remember?
yeah, that's function. I do like put the output of function. So it's like just one.
Two. Five. Right, this is minus one. Over. Five.
Okay, so a composite function
There's only like.
is. What's the definition of composite function? Yes, Baron for 300.
In another.
Are we good with that? A function within another function, like the warm up today. Wasn't it a composite function? Let's see.
Not really.
Let's think about the path that x took. First thing that x did was be multiplied by 4π/3. It went into that function, and then from that, wasn't there an output that went into sine?
Yeah,
It's a composite function. It's not like you haven't done them before. Sometimes they're just like hidden, but that was a composite function. When you see this circle, please don't ask me on a test if that is a multiplication sign. That is a small hollow circle that represents we're dealing with composite functions. And do you know how to read this?
of G of 5.
You are correct that this is the same thing as f of g of 5. But to read it with this doesn't say f of g, and it doesn't say fog. Composed with, yeah. Technically, this is f. Do you write some math books? Oh, you're just a lefty. That makes sense now. Okay. F composed with that's wig. With g of x. Right? That's
You don't say it like.
five. I'm not gonna be marking you down or up based on how you pronounce it or how you say it. I just want to tell you that specifically that's how to say it. But really, this is what you need to know that it means f of g of 5. So a lot of people do way too much work here. Really, the only thing you have to do is figure out what is g of 5 first. Do you know what g of 5 is? It's 5 plus 4 over 2 times 5 minus 5, isn't it?
So it's 9.
9/5, is that right?
Then you plug 9/5 into the x in f,
Perfect.
and then you get a number.
Yeah, then we do the f of 9/5. So the output of our preliminary function becomes the input of the secondary function. So that 9/5 goes into f. So we have, I'll let you finish this. Let's see if you could do it in an algebra 2 method instead of a 6th grade method. Could you do this simply? Check with your neighbor when you're done with stock. Simplest way to do this would be to
You just solve.
just solve it.
You put 18/5 on the top and you subtract 5/5. You have 13/5 over -1/5. The bottom. I am.
That's a good way to do it. That's a really good way to do it. What's another way?
Are you saying like it's a common denominator thing?
Yeah, well, there's no common denominator. There's one denominator. But if we multiply top and bottom by
2 minus 9/5. Or plus 2.
multiply by 5. So we cancel the little denominators if we do that. Let's see, 2 times this mess is going to be 18, isn't it? Do you see that? That's 18. And then
5
minus 5. And then over 9 minus 10. Did I do that right? I think this is a nice, pleasant way to do this. You could do it however you like, but I don't want you to forget that you could cancel the little denominators like that. Of course, that answer I would give you -1. I need -13 as a final answer. Make sure to always simplify. Keep your negatives out of the denominator. And I don't want to ever see over 1 either. Would you please find this next one? Did you get it? Can I call? Needs to check before I call someone? Terry, could you give us your answer? 7? Do we agree? Okay, thank you. So what property do the last two results imply is not true about the operation of function composition? Remember the word here. Hey, Lyra. Not, is it associative? Is it commutative? Yeah, what's that word, right? It's one of those. It's
You and that.
there you go. Yeah, for multiplication, we know that A times B equals B times A. That's commutative property. So it does not work for compositions. Let's see, is not true. Okay, commutative property. Okay, there we go. Okay, find the domain of F composed with G of X. Okay,
And using the F, ones from the.
yeah, using these same ones. So first I'll say we're doing F of G of X. We know that G of X is X plus 4 over 2X minus 5. Are you okay with the rest? We're actually going to find F inverse of X before we talk, and then we'll talk about domain after. Make sure to simplify your answer.
I would hear.
So that's what I see.
Bringing God.
Well, actually, it's not saying seven.
We should do that.
Yeah. I mean, he's.
Okay. You about ready?
Not just.
Yeah.
Long feet. I think he's counting this one now. Yeah, 14 thirds with me, because this is inverse trig. Wait, I don't understand how this is inverse trig function.
Oh, we're not doing trig yet. Yeah, this section has nothing to do with trig.
But that
The next
doesn't
unit,
count.
the next unit.
No, it doesn't. It's inverse trig.
Yeah, mine says inverse trig. Mine says it's the sum.
Oh, that's the title of the unit. That's the title of the unit. That's unit 3. But don't worry, we'll get there. Right? Just tomorrow's gonna be inverse sine. That's the inverse trig. We have to talk about inverse functions first. Okay,
Oh,
That's-
I see how this is gonna happen.
as I'm working with this, the first number I have to write is the first number I have to write when going from here is a 2, isn't it? 2 times, is this what you did? X plus 4 over 2x minus 5, this mess? Did you do that?
Yeah.
So I'm taking this and plugging it into here. Right? That's what it's saying to do, F of that monstrosity of an input. So I have that, 2 of that, and then minus 1 over. Thank you. X plus 4 over 2x minus 5 minus 2. Do you all have that? Okay, is that acceptable as an answer? Not acceptable as an answer. So to clean this up, I'm going to let's get rid of the little denominators by multiplying top and bottom by 2x minus 5. What property am I using when I do that? Identity property multiplication. Anything times 1 is itself. So this times this leaves us with 2x plus 8, and then we have to distribute. Danger ahead, right? Minus 2x minus 5. Or you could distribute that negative immediately, and then we're left with x plus 4 minus 2 times 2x minus 5. On top, we're left with 13. On the bottom, we're left with negative 3x plus 13. Is that right? Plus 14. Are we good? Now we have to talk about the domain. So if at least express the composite function for the domain. All values of x that don't result in tragedy. And what I mean by tragedy, either undefined or like taking the square root of a negative number. Because generally we don't deal with imaginary numbers when we're talking about domain. So like here, I see right here, there's a problem. If x is equal to 5/2, that's tragedy right there. We're trying to plug in something that's undefined into a function. How does that work? Doesn't. Now, some people are tempted to say, well, okay, x can equal 5/2 and x can equal 2. But is x equal to 2 ever a problem in here? It's never a problem. So what else there would be a problem for x to be? Do you see it? Yeah, right there at the bottom. So also can't equal 14 thirds. Did I do that right? There you go. So it starts with the inputted function. That's you're looking for a domain of the inputted function, and then the domain of the entire composite. That gives you your full domain of the composite. By looking at this, we would never know, like at the very end, we would never know that x can't equal 5/2. Yes, Aiden?
You could plug in like the whole thing, or can you just say like, let me know if we know f of x is 2x minus 1 over x minus 2. You just plug in like x plus 4 over 2x minus 5, which is g of x minus 2, and set that can't equal 0. So just like the.
Oh, so like, I see what you're saying. So you're saying like go here. And then from this, just say that this can't equal 2. Is that what you're saying? Does that make sense that expression I just highlighted can't equal 2? Or that the first one can't equal 2? Nice. It'll always work out the same. You can either go back to that one and just say that whole thing can't equal 0, or finish it up and say the denominator can't equal 0. But that is our composite function, and our domain is everything but these two numbers. All right, let's move on. Sometimes you'll be given a composite function, and it's up to you to define which functions could be composed to make the given function. In cases like this, it's important to understand that they're inside, outside functions. So we want f composed with g of x to equal h of x, which means we want f of g of x to equal h of x. So the inside function we're going to label as g of x, isn't it? Inside function. And then f of x would be the outside function. Now, what do I mean by this? Now we're going to do a few different versions of this, so make sure to not fill the entire square. So inside function, probably the most obvious one is that g of x is equal to, I heard it, 1 plus x squared or x squared plus 1. And f of x would be equal to x cubed. I hope that that makes sense, that if you plug this into here, the result is a function with which we started. So I'm going to call that version 1, v1. v2, you can think of another pair of functions that would result in the same composite. Thank you, yeah. We could say that g of x just equals x squared. Do you see what the outside function would have to be if that's what we're plugging into? 1 plus x is what you said? Do you see how that results in the same thing? How many more are there? There's infinitely many. I'll say v3, g of x could be equal to 5 plus x squared. If that's the case, then f of x would have to be equal to x minus 4 cubed. That's a ridiculous example, but it works. On a test quiz, I recommend you choose the first one. The one that's grouped together should be the inside function. I'll do one more. Volume 4, g of x is equal to x. Do you see what the outside function would be if g of x is equal to x? Yeah, that'd be.
How would you feel if we wrote that on?
I think I have a really good sense of humor.
And
I couldn't give you credit.
oh,
Yeah. Like here it says, without using the identity function, y equals x. This is y equals x.
oh,
So it's kind of a cop-out that will always work. And yeah, so thank you for helping with that. I'm going to put an x through that. Okay, you cannot use that. That the inside function cannot just be x. Or another variable. You can't say, well, how about m? It can't be a single variable. Please. I think you can do h of x. I'll give you a minute to try that. Check with the neighbor when you finish, and I'll call on one lucky individual to share that with us. Can you check with your neighbor? I want to call on someone in just a few seconds. Okay, Kayla, what'd you get for the inside function? Okay, and the outside? Do we agree? Thank you, Kayla. Can we move on? Let's do it. For those of you who heard of one-to-one functions, would you go ahead and discuss what you remember about one-to-one? And if you don't know, listen in to what the people around you are saying.
Like one plus. Makes it.
Like the.
Oh, it's like not.
Yeah.
Well, for everybody.
Or it could be, it could be a line or execute, right? But it's just a,
Yeah, she has more intelligence.
yeah, it's like this is bad.
Okay, so one-to-one. What do you remember? Aiden for 200.
Said that it was when a function has is true so that for every one output, there's one input, for every one input, there's one output, so like on the graph, it passes the vertical and horizontal line test.
Okay, does that sound familiar? Nice. Any other? Yes, Baron,
So
400.
say that the function has an odd multiplicity.
Would that be enough?
Oh, I guess it still could. But anything with E doesn't work.
Okay, anything that's even doesn't work. Okay, mostly. I think you're right. Yeah, I can't think of a new function that would work.
Does
They
it have-
both-
does it just have to have a multiplicity of one?
Multiplicity of one. Well, there are so many different types of functions. I don't think we need to bring in multiplicity.
3 words.
Oh, x cubed. Yeah, that's true. X cubed. Yeah, that does work. But I don't know about like x cubed minus 5x squared plus x. So different cubic functions, I don't know, because it could have like humps. Okay. So the difference between a function and a one-to-one function is a single word. And I think they messed up here. It says here, recall that a function is a relation where each x coordinate in the domain is assigned a unique y coordinate. I think this is supposed to be a one-to-one function. We call that a one-to-one function is a relation where each x coordinate is in the domain is assigned a unique y coordinate. So here's a function. Whoa. Can't see my email. Just a second, please. Okay, there we go. Okay. This is a function. Now, it seems to me that the domain and range don't need to be labeled because we already know that the pink is the input because of. Yeah, but I mean, I feel like those words are redundant because we already know that pink is input because
Left and they have the arrows going.
the arrows are directional. So, yeah, this is the domain, this is the range. We know this is one-to-one because each input is paired with a unique output. This one, is this a one-to-one function? What's the problem here? Right, same output. What do these 3 dots represent? I forgot. Therefore, actually not one-to-one. Not one-to-one. Is it a function even?
Yeah. That's fine. As far as you're concerned.
It's a function. This one. Discuss with your neighbor. These two. What is it? How do you know?
But is it a horizontal?
No, not one.
The ones past the board, like, was.
No, horizontal and vertical. Yeah, but like this way.
Yeah, it has to go.
Oh, yes.
This one.
Yeah, it says passing forward.
Okay, so this graph here, is it a function? Yes, it's a function. We know because passes a vertical line test. Is it one-to-one? How do you know? Doesn't pass the horizontal line test. Does that sound familiar? Horizontal line test, it works the same as a vertical line test, but it's a horizontal sweep. Right, you're looking at this, an animation in your head would take this line and move it up and down, and if it ever crosses more than one point, it is not one-to-one. I hope it makes sense. Like if I just take these 2 inputs, notice that they have the same output. It's not unique. There has to be a unique output for each input. So not one-to-one, but it is a function. This one, is it a function? Why is it not a function?
Y value are the same X value.
Yeah, this is a problem. Each input has to have exactly one output. F of 1, if I ask you what F of 1 is,
Couldn't tell you.
even Baron couldn't tell us. It can't be done. How about F of -3? Do you know what it is?
Yes.
Well, no,
From this,
it's not a
there's no
function.
add.
It's not a function, so it seems like it would be six. It's definitely paired with six, but f of would be inappropriate notation for this because it's just not a function. You just can't force it into being a function. Okay. If a continuous function is decreasing over an interval, can you determine if it is one-to-one on that interval? A function is decreasing. Let's see.
Oh, yeah.
Let's say the interval is from A to B and we start like over here. And can you imagine what it's going to look like if it's decreasing? Maybe this.
Even then, it's still fine.
Is that one-to-one on that interval?
Yeah, but it's.
Does it pass the horizontal line test?
And
That's what-
Yeah.
But it's a whole.
How about if I'm just talking about on the interval. So this is mostly decreasing. Yeah, I think it says it's decreasing over the interval. This is decreasing, a little increase and then decreasing again. So we can't say anything if it's mixed, but if it's only decreasing or only increasing, we can say that it is one-to-one on that interval. And that interval could be from negative infinity to positive infinity. So the answer is yes. Aiden, did you have a question? Or did you have a comment? Oh, okay. Yeah, interval.
Always.
Yeah, is it necessary for the function to be continuous? When is a function not continuous? As a whole or an asymptote?
I guess it's bar goes by, so.
Yeah. It does.
Yeah, let's take a look at a function I hope you're familiar with. Y equals 1 over x. Do you know what this graph looks like? I did a crossover. First quadrant and third quadrant.
Which is fine.
Is it always decreasing? On its defined interval, is it always decreasing?
Yeah, it is.
Yeah.
Yeah, it's always decreasing on its defined interval. Yeah, this is definitely one-to-one. So is it necessary to be continuous? Nope. Okay, the time is 2:29. It's 2:32. I'll resume the lesson. You have a few minutes to zone out and stretch if you like, or talk. I think rugby is the closest water fountain.
We like
I realize
cafeteria.
Can we use the restroom?
If you need to, this is a good time.
I heard that you have a rule where it's like, oh, in bathroom.
I asked students to have a personal goal.
Not a hard cutoff.
It's not a hard cut. If you gotta go, you gotta go. But if it's every day, that might be a problem.
Good dreams should be.
I saw from the back,
We beat
I was wondering why there was a.
That was so freaking.
Medium.
Do you know, like, the picture?
Mr. Will you be able to grade my test? That makes sense.
I'll do my best. By Monday? Definitely by Monday.
Okay.
If we you said.
Now it's.
That is.
And then you isolate it, that's
What's your best?
yeah, and it reverses whatever, so basically we do all. Yeah. Yeah.
Okay, 232. Inverse functions. You already know what inverse operations are, like the inverse of multiplication, division, inverse of addition. So what does it mean for two functions to be inverses of one another? Well, actually, would you take a moment to discuss with your neighbor if they remember what that means for two functions to be inverses? Alex, remember, you're not alone.
So if you have this.
I agree.
it's like you plug in the one, you make that.
Y equals X?
What?
Just Y equals X.
There's not a letter, I wouldn't think of a letter for like, how does react?
Not that I know of. That'd be interesting.
I just know like.
Probably.
First.
I don't know, it'd be one. I just know that's the inverse.
Yeah.
By like.
So inverse function, what does it do? Or two inverse functions, what do you remember? What do you know about them? I'm curious. Yes.
When you compose the original function with its inverse, it produces x.
Ah,
So if they undo each other.
okay. So when you compose say that one more time.
Compose the original function with its inverse function, it produces x.
Okay. So when you make the composite function of a function and its inverse, the result is just going to be X. Ooh, nice. Thank you. What else? Yes, Baron for 500.
We're symmetric about the line y equals x.
Does that sound familiar? When graphing a function at its inverse, it has symmetry about the line y equals x. Good. Anything else? Okay, because at the heart of it, all inverse functions, well, all an inverse function does, it takes the input from becoming an output and change it to that output going back through the function, going back to its original.
And only
Self.
one-to-one functions have inverses.
And only one-to-one functions have inverses. Perfect. Yeah, if it's not one-to-one, we wouldn't even be talking about an inverse at all.
The inverse is like 2, 1 would be 1, 2.
Yes. Perfect. Yeah, if f of x was 1, 2, then the inverse, and could you just check with your neighbor, how do you write the inverse of a function? Don't call it out, just how do you write the inverse of a function?
Is there like five? Wait, oh, wait, yeah.
I'm gonna move this over, by the way, because we have to write some stuff in here. Okay, so the inverse would be f like this. Does that look familiar? That little exponent?
Yeah.
So this is just a tiny example. If 1, 2 is a point on f of x, then 2, 1 would be a point on the inverse of f of x. When you read this, please don't say to yourself f negative 1. Please don't say f to the negative 1. That means something completely different. This is not an exponent. It's really clunky notation to denote that we're talking about the inverse. So when you see this, I want you to read in your mind, hold yourself accountable to it. I want you to read f inverse of x. Did you get that? Make sense? Y'all gonna do that? I know it's gonna be tough. Okay, so the process is step 1. If you have a function, you want to write the inverse. Step 1 is to
Yeah, it does.
switch. I think that's what you mean, right, Aiden? Switch to x and y. X and y. Step 2. Solve for the new y. 3. We're kind of done there, but replace y with f. How do I write this? F inverse of x. Okay, I'm going to change the function here. F of x equals square root of x minus 3 plus 2. So we're going to find the inverse function and determine the domain and range of both. So go ahead and find the inverse of that, please. Meet your hand, question.
Let MC or alphabets equal one.
No need to do that. Thank you for asking. We're gonna skip that second one, by the way. But you're working on that square root of x minus 3 plus 2. Oh, no need. Thank you. Yeah, it doesn't have to be standard form. Did you get it? Did you at least get the inverse? Did your neighbor get it?
-2. So you should, well, no, it should still be just that. Just minus 4. It's not plus.
Because you have
Yeah, like, this is why plus 10 to the other side. Should be y minus 3.
the inverse of that.
Oh, I see.
Okay, ready or not? I'm not going to call on someone for this. I'm just going to do it. Did you start with x equals square root of y minus 3 plus 2? You did that, right? Next step. Subtract 2. I'm going to move my y's to the left just because I'm solving for y, so I want those on the left. Are we comfortable with that? You can keep them on the right if you want. Of course, the next step is to square both sides out. My goal here is to solve for y. So should I expand this x minus 2 squared? We don't have to. It's fine as it is. And now I'm going to add 3 to both sides. And at the same time, I'm going to replace the y with f inverse. Thank you. Poorly done. F inverse of x equals x minus 2 squared plus 3. Yes? Okay, now we aren't done because if you recognize this function, you recognize the shape, don't you? It is a parabola. The problem with parabolas is that they are not one-to-one. So how could it have an inverse and how could it be the inverse of another function? I'll give you a moment to discuss this. How is this possible?
Oh, is it because the square root function is only on that side? Something to do with that.
Yeah.
X or root x is only on this side.
So anything? We have to consider the domain and range of both of these. So let's do this. F inverse, domain, and range. I'm going to make a little chart here. Let's do the domain of f of x. Do you see what the domain of f of x is?
Gotta be 3 or bigger.
Yeah, right. We take the contents of that radical, make sure that that's greater than or equal to 0. So x is greater than or equal to 3. Yes? Did I do that right? Like if I try to plug in 2 to the original function, there's going to be a little bit of a problem. I'm not going to be able to graph that. The smallest number I could plug in is a 3. Then any number after that is fine. But how would I get the range out of that? Why is it 2?
Because the whole thing is shifted up to the normal root function.
Yeah, the smallest 3 can be 0 and 2.
Nice. So you can think about this graphically, or you can think about it analytically. I probably tend to think about the graph, where we know the square root function looks like this, and then that just moves 3 to the right, and then 2 up. So you can see that domain going from 3 to infinity, and then the range in the y collection 2 to infinity. Or it is what you said.
Well, I just said that the square root, that area can only, this has to be greater than or equal to 0.
Yeah, right, this isn't gonna ever take away from the 2, will it? The smallest this could be is 0, and then on top of it, just add to it. But I like the idea, especially since it's set up to be a parent function. I'm gonna just graph it a little bit. I have a 3 right here. I have a 2 right here, so I know it's gonna look like this. So I know that now that the range is y is greater than or equal to 2. I need to do the inverse function. And remember, since the x and y's are flipped, all we're going to do is take the information from domain and range and change them. I'll do the range of the inverse function first. So it's going to be y is greater than or equal to 3. Is that clear? And the domain is x is greater than or equal to 2. So it is a parabola, but think about where the vertexes of this parabola would be. At 2, 3, correct? So it looks something like, normally it would look something like this and this. 2, 3, no? The square is what makes it a parabola. It's just a shift 2 to the right. But remember, the domain is just x is greater than or equal to 2. So I'm going to cross off the left and notice that these two functions are reflections over the line y equals x. Yes? Okay, let's try this one on page 6. I want you to find the inverse, find the domain and range of both functions, please. Just this one.
Are these ones to make an inverse or no?
Please write the inverse and then find domain and range of both the regular function and inverse. Yeah. You are done or stuck. Check in with your neighbor. Oh no, just the first one. Just a rational function.
Oh, wait, that's so real. Do you know? Oh, wait, the one.
I'm going to be calling on someone to help me create the inverse, by the way. I know it's a tough one.
Maybe this is the domain. No, that's the domain, not the range. So I think the domain of the problem is the range of, what's the range of the person is a domain?
Yeah. My first thought was.
Oh, my God, it has to be.
Yeah. You just find it.
You just know that something.
Yeah, the X domain.
Wait,
For the original.
This is the. Yeah. So we binding the domain. Yeah.
I'll be asking for help in about 10 seconds. Okay, so ready or not, let's hear what Alex has to say to help us build the inverse function here.
Like you just want them.
One step at a time, please.
So we started in by just replacing f of x for y.
Okay.
Then I multiplied by y plus 2. So x times y plus 2 equals 5y minus 1. Then I go.
I'm gonna put you on pause for just a second. If you do this on a test or quiz, by the way, you've already gotten a considerable amount of points if you just switch to x and y. It's not like you're going to get 8 out of 10, but you probably got like 3 out of 10 so far just by switching to x and y. So I'll do something when you're building the inverse. Okay. Yeah, then you're not going to get the rest. But luckily, Alex knows, so I'm sorry to interrupt. Please continue.
Then I subtracted by 5y minus 1. So x times xy plus 2x minus 5y plus 1 equals 0.
Okay.
Then I group them together. So xy minus 5y plus 2x plus 0 is 0.
xy minus 5y equals what?
Equals negative 2x minus 1.
Nice.
And then I took out the y from one side, so y times x minus 5 equals negative 2x. And then I divided by this.
Nice. And look, go ahead and replace the y with. Oh, nice. Alex, thank you for reminding us about the proper way to say this. The inverse function of f of x, or f inverse of x equals that. Are we good with this? Any questions? Oh, you just want to play with it a little bit? Okay, so we could do that. Okay, now this is worth full credit, by the way, right there. We're already, so right now we're just playing, doing some aesthetics here. And what do you recommend doing from there, Josephine? Interesting. Something like this. Okay, it scares me a little bit, but if it's done like this, I'll be fine. It's okay. But let's make it a little bit prettier. Is we're doing some aesthetics here, so what's that? Yeah, let's put this down here on the bottom and just make it 2x plus 1 over 5 minus x. Isn't that nice? But I couldn't care less which one you do. But if you do something like put that negative here, right? If you negative here instead of for the fraction, that would just be wrong. So just be careful. If you're going to play with it, clean it up. Make sure that you are doing so carefully. I'd hate to have you have a right answer and then just get it wrong for no real reason, except for aesthetics. Alex, thank you for your help. Did you already have the domain and range, everybody? Okay, I want some help with the domain and range. Sage isn't here, fortunately, but Julia's here. Were you able to get domain and range for these, for any of these?
Function, I got that x can't be -2. So for the range for the inverse, then y can't be -2, and then for
Just a minute. Are we good with that? How she did? We went right to that. Thank you. Keep going.
for the inverse, I got x can't be 5. So for the range of the inverse of the sorry, no, not the inverse, I can't be 5.
Okay. Any questions?
Yeah. Why can't y be 5?
If you look at like the inverse, it's the numerator is initial is x minus 5, so that would be.
Oh. Oh, if you found both domains and applied both.
Yeah.
Really, really good way to do it, because that's the low hanging fruit, right? X can't be -2, X can't be 5. And then use that to find the range of the other ones. But let's talk about your knowledge of rational functions in the graph. Tell me why this makes sense, why y can't equal 5 based on your knowledge of the graph. Please don't call it out, let's please discuss quietly. Now look at this, you might already know that y can't equal 5.
Oh, ratio,
Let's
yeah,
talk about
it's no one's just balanced. That four double because ratio never really correct. It's
Bottom.
it's the. What we have.
So what is it? It has a horizontal asymptote at y equals 5. Now we know that horizontal asymptotes can be crossed. But if it's a linear term over a linear term, it never is. It just never is. So in this case, it makes sense that y can't equal that horizontal asymptote. Just a nice connection. And the same thing here. Does it make sense that y can't equal -2 for the inverse?
Yeah.
It's also the horizontal asymptote of the inverse. Now, I just want to play with this a little bit. What is f of -3 equal to? Yeah. Is 16? -16 or 16? 16. Okay, I want to check. What am I going to check here? F inverse of, is it going to work? What should it equal?
-3.
Does it equal -3? I'll go to this cleanest one. 32 plus 1 over 5 minus 16. 33 over 5 minus 16, -11. Look at that. Right, that's what inverse functions do. It takes the x's and y's and just reverse the direction of them. Let's see what you can remember about this one. You may want to discuss because there's some notation you may not have seen in a long time.
It's always you. Always. Just watch it.
Yeah.
I actually hate.
I like it.
Check with the people around you. If you and your partner don't know what to do,
No.
discuss.
To the. Yeah, right, log-based e of x.
The function inside is.
E to the x.
I put the same.
I just remember one.
I like don't.
Like something like, yeah.
That's okay.
I know like there's like something in like.
Well, no.
I
Log.
Oh, there you go. Okay, nice.
Then like you can like.
Why?
Nice. I'm back.
Oh, boy, not 2 to 1.
Okay,
It's negative.
so
But it's 1/3.
It looks like it's back.
So this problem, it's okay if you don't know how to deal with it right now. It's not going to be on homework. It's not going to be on the test. It's not going to be on the quiz. We are going to have a chapter after our trigonometric units are finished to deal with this. But this is just for people who may remember something like what is that in between the 1/3 and the parentheses? That is not in, right? That's ln. So you may remember that y equals ln of x is the same thing as saying y equals log base e of x, and e is Euler's number. Yeah, just let's see what you got. E is approximately 2 point something, 2 point 7-ish, 2.7-ish. And again, you don't need to know this for this chapter. You don't need to know it. That we're just kind of warming up for a couple months from now. So I'm going to rewrite this as maybe immediately. Let's say x equals 1/3. I'll just call this log base e of 2y minus 1. Because if nothing else, you should at least be able to replace x and y. Nothing else. And if you didn't know the log base e, just copy the ln. Okay, next step. Who'd like to talk me through this? Yeah, Josephine.
Here on both sides. To get 3x equals log e 2y minus 1. And then from there, I took both sides and put it like e to the power of the thing. So then you get e to the power of 3x equals 2y minus 1.
Just a minute. Does that bring back any sort of memory right there? We are definitely going to do this from the beginning again. So I don't want you to stress out. I definitely don't want you to like go look up stuff how to do this on YouTube or get a tutor about this. We're going to do it. Josephine, please continue.
1 subtract by 2. So you get
Add 1 and do what?
that, subtract by 2.
Subtract by 2? I figured that's what you meant. So you add 1 and then divide everything by 2.
Plus 1 divided by 2. Or
Yep.
sorry, f negative 1, f inverse.
F inverse. Thank you. F inverse of x equals this. So that is, thank you, Josephine. That is the inverse of our logarithmic function. Are you going to lose sleep over that?
Probably at some point.
Oh, because you're excited about it? That makes sense. Okay. That was great, Josephine.
Yeah.
Oh, no, it was the trigger. What's that?
When's the unit coming? Like
After log. After, after Christmas.
that.
Okay, folks, great job today. We handled a lot. You did great.
Yeah.
Pardon? Yeah, homework is on the hub already.
We can have, like,
It's literally just